Did you know that a single hard drive failure could wipe out all your data? Whether you're running a business or just protecting personal files, losing critical data can be devastating. But what if there was a way to ensure your data stays safe, even if a drive fails? In this video, I'll break down RAID storage, your ultimate solution for data protection and performance. From RAID 1 mirroring to RAID 5 parity and RAID 10 speed, you'll learn how to safeguard your data and keep your systems running smoothly. Ready to stop worrying about data loss? Let's dive in and master RAID storage. RAID storage. In this course, we're going to talk about storage. Storage is a very important element, especially in fault tolerance. The worst that could happen to a business would be a hard drive failure, which would lead to data loss. That's why the ideal is to find a solution to ensure that if a disk fails, and although no data loss occurs, one of the best ways to ensure data recovery is through RAID. So no, it's not a special unit. Rather, it is a set of measures to distribute storage between several hard drives. In fact, the word RAID stands for Redundant Array of Independent Disks. In a RAID configuration, data is copied to multiple disks, which means that in the event of a breakdown, no data will be lost. There are a total of 4 levels of RAID: RAID 0, RAID 1, RAID 5, and RAID 10, also known as RAID 10. RAID 0 is not very useful, as it is not fault tolerant. It shouldn't even be a type of RAID, as not only does it offer no fault tolerance, but it also increases the chances of data loss. Because in a RAID 0, the data is not duplicated, but it is actually spread over 2 separate disks. This means that if only one of these disks fails, then all the data will be lost. So, the only reason you'd want to use RAID 0 is for speed, because when 2 disk controllers work instead of 1, then access to data is much faster. As you can see, the weak point of RAID 0 is its reliability. If a hard drive fails, all data is lost. Now, let's move on to RAID 1, which is very fault tolerant. In a RAID 1 configuration, data is copied to multiple disks. In this way, disk 2 contains exactly the same data as disk 1. That way, in case of a failure of a single disk, there will be no data loss, because the other disk will have a carbon copy of the data. RAID 1 is therefore the constitution of a cluster where the information is replicated on each of the hard drives. It is said to be a mirroring architecture. We will now talk about RAID 5. RAID 5 can be used with at least 3 drives. In the example, we took 4 disks. This is arguably the most commonly used RAID, as it is extremely fast and can store a large amount of data. In a RAID 5 configuration, data is not duplicated, but is spread across multiple disks. And as we can see on the diagram, on each of the disks, we find a very important piece of data, which is parity. This data is also evenly distributed across all disks. Parity is used to reconstruct data in the event of a failure of one of the disks. But the downside with RAID 5 is that the equivalent of an entire disk is used to store this parity, which therefore greatly reduces the amount of data available. For example, if each of the disks in the topology is 1 tera of data, this gives us a total of 4 tera. Well, in a RAID 5 configuration, the total amount that would be used for data storage would be 3 terabytes, because the equivalent of an entire disk, i.e. 1 terabyte, would be used just to store parity. And the last one we're going to see is RAID 10. So as its name suggests, RAID 10 is a combination of RAID 1 and RAID 0. Here, you have to use at least 4 disks. In a RAID 10 configuration, a set of 2 disks is mirrored using a RAID 1 configuration. When we say mirrored, it means that the data is replicated identically on the 2 disks. Then, these 2 sets of 2 disks are grouped together in RAID 0. The advantage of RAID 10 is that it has the fault tolerance of RAID 1 and the speed of RAID 0. But the downside is that you can only use half of the storage capacity. That is to say, if you use 4 disks in a RAID 10 configuration, well, you will only be able to use 2 for storage.